Okay, now we discuss on the question number 10. The boost converter with the following parameters. So we transfer all the data into the circuit, which is we have here the boost circuit. The boost converter circuit with the parameters given inside the statement of 20 volt incoming, 0.6 duty cycle, 80 microfarad microhenry of inductor, 50 ohm of our load, then 100 microfarad of our capacitor. So means that we are having this circuit. We want to evaluate what are the behavior of this circuit. So verify that the inductor current is discontinuous. So we want to check, is it the inductor given here is enough to provide the continuous mode of our load current. Okay, we need to know what is the source of voltage. We need to know what is the resistor value of our load. This is the value given. The source voltage we calculate later. So we need to verify, is it the inductor current, the inductor provided is sufficient enough to provide CCM for our circuit. So from the formula, L mean for boost converter is 1 minus D squared times R times D divided by 2F. So 1 minus 0.6 squared times 50 ohm times 0.6 divided by 2 times 25 kilohertz. So we shall get 96 microhenry as our required value of inductor. Means that 80 microhenry of this provided inductor is not enough for the CCM. So we must verify that the inductor current is on the discontinuous mode. So next is our V out. So V out is equal to Vs 1 over 1 minus duty cycle. So Vs is 20 volt, 1 minus 0.6. So the output voltage is also at 50 volt, 50 ohm, 50 volt. Okay, see what are the maximum inductor current. The maximum inductor current that passing through 80 microhenry of that inductor. So Vs divided by 1 minus D squared R plus. So Lmax is plus, Lmin is minus. Vs times D divided by 2F L. So you have 20 divided by 1 minus 0.6 squared and 50 plus 20 times 0.6 divided by 2 times frequency times the value of our initial inductor just now. So the Lmax is 2.5 plus 3. So we have 5.5 ampere of our maximum inductor current. Okay, that's for question number 10. Okay, next we return to question number 4 on the buck boost converter. We have discussed on buck boost and now on buck boost converter. So we have here the output of 12 volt. So we draw the circuit and transfer all the data into the circuit. We draw the circuit of buck boost converter. We put in all the given parameters. Output of 12 volt, 25 watt, coming from 24 volt source with 100 kilohertz of switching, and the expected output voltage ripple of only 1%, and should conductor in CCM mode. So first of all, we need to find out what is the duty cycle and also the resistor value of the load. Okay, V out equal to negative V source D over 1 minus D. So for buck boost, actually the output polarity will be reversed from the source. So that's why you have negative over there. So 12 input equal to negative 24 times D divided by 1 minus D. So D now we calculated as 0.33. So for CCM, the minimum inductor value should be 1 minus d squared times R divided by 2F, which is 1 minus 0.33 squared times R. But R here, we have to calculate from the circuit, which is P equal to V square over R. R equal to V square over power. So power is 25 watt. 12 squared divided by 25, we have 5.76 ohm of R divided by 2 times 100K. So we have 12.93 microhenry of our inductor value to maintain CCM for this circuit. So if there's not mentioned any kind of limitation, so for general, when we have calculated the minimum inductor value that required for CCM, we shall increase another 25%. This is general consideration for practical design. Increment in terms of 25% to make sure that at any time the CCM is happen on the circuit. Is that you might have an extra load on the device, so it will maintain at continuous current mode. So 12.93 microhenry times 1.25, so we get 16.16 microhenry for our inductor value that we should assign to the circuit. Then we find out what is the inductor average current, which is equal to Vs times D divided by R, 1 minus D squared. So we have here 24 times 0.33 divided by 5.76 of that resistor value. So we get 3.06 ampere of average. 3.06 ampere of average inductor current. To look out on the maximum inductor current, IL max. So IL max, from our formula we found that was IL average plus the difference between your maximum and minimum range divided by 2. So IL max plus delta IL divided by 2. Okay, IL max here we have already 3.06 plus for delta IL over 2 is V source times D divided by 2L. So we have here 2LF actually. So 3.06 plus 24 times 0.33 divided by 2 times 0.16, 16.16 microhenry times 100K. So the value we use the value which already increased by 25%, because this is minimum to make sure that the system operate on CCM, but we increase another 25% to make sure that at any load variation here, the system is still confirmed to be under or within CCM mode. So we get IL max of 5.51 ampere. So same goes to IL min, which is IL average minus the difference between on the range of IL divided by 2. Okay, so we should get the IL min of 0.61 ampere. Means that if let's say we still use of minimum here 12.93, the IL min should be 0. But when we increase another 25%, IL min increase above 0 to become 0.61 ampere. Means at any load should be the output should be at positive mode. The current should be continuous. So in terms of C, so it's mentioned over here, the delta V naught, V out over V, the difference or the range of our output voltage. This one is current regulation, this one is voltage regulation, should be within 1%. So delta V naught, V out over V average V is 1%. So the value of C we can calculate by dividing duty cycle with R and range, and also times your frequency. So 0.33 divided by 576, the value of our resistor we calculated just now, times 1% times frequency of 100 kilohertz. So we shall get our required or minimum capacitor value of 557.29 microfarad. So actually on in our circuit, in our catalog, there is no such as values of 57.29 like that. So this is minimum. So we can choose any 60 microfarad or whatsoever, such that it could provide or produce a better regulation in terms of voltage regulation to the circuit. So there will be no such values like this. So you just find the nearest value, which is next bigger size, to accomplish your circuit. Okay, that's for question number 4. Okay, next is buck boost on question number 7. So you have here the question of design a buck boost converter that produces negative 15 volt. So we have a source that varies from 12 to 18 volt, which need to produce 15 volt regulated. So we have two range of source, 18 maximum, 12 minimum. So it will fluctuate between 12 to 18, maybe reduce down 15 like that. The maximum is 18, minimum is 12. So we need to regulate at 15 volt at any time. So what do we need to do? So input is at this, output is regulated. So what we need to do in terms of, we want to set in terms of duty cycle range, in terms of their inductor and capacitor value. So we have a circuit, we draw the circuit of boost converter. So we put in all the available data into the circuit, such as the input voltage from 12 to 18 volt, the expected output voltage regulated at 15 volt, and the values of resistor of our load, which is 15 ohm as well, and our frequency, switching frequency of 100 kilohertz. So we need to design a buck boost such that we need to determine what is the components value, such as duty cycle, inductor and capacitor. So that's the three things that we need to include, because it's not mentioned yet inside this system. Okay, what do we need to do then? So we know that for buck boost, we have the formula is V out equal to negative Vs times D over 1 minus D. So we have two conditions here, the range of 12 volt and 18 volt. So we put the consideration at two range here. So we set at 12 volt condition and we set at 18 volt condition. Try to find out what are the range limit in terms of their duty cycle at 12 volt and what happened at 18 volt. So in between we can shift in between. Okay, for 12 volt we have here input of V out of 15 volt equal to negative 12 volt output source times D over 1 minus D. So we calculate for D, we get D equal to 0.556. Meanwhile at input of 18 volt, so we calculate and find out the D, the V out equal to negative 15 equal to negative 18 divided by D divided by 1 minus D. So D is 0.55. So for 12 volt 0.556. For 18 volt it will reduce to 0.455. So next we try to find out the minimum. We assume that this design is to be conducted under continuous current mode. So try to find out the minimum component for L to make sure that this system to operate under CCM at all times. So L mean is equal to 1 minus D squared times R divided by 2F. So for 12 volt condition, 1 minus 0.556 squared times 15 divided by 2 times 100K. So we get the L minimum of 14.79 micro Henry. So for 18 volt, the value is 1 minus 0.455 duty cycle squared times 15 divided by 2